Hello, scholars. So today we're going to be learning about electricity. We're on TEK 5.6b, and our objective for today will be the students will demonstrate that the flow of electricity in circuits requires a complete path through which an electric current can pass and can produce light, heat, and sound. So think about it. What are some ways that you use electricity every day in your home, and how does the energy flow to make these devices work? So I want you to always make sure you have a sheet of paper and pencil to kind of jot down your ideas and your thoughts throughout this entire mini lesson. Okay, so for extra credit, you can complete these activities in the mini lesson and submit them to me. So go ahead and answer those questions with someone in your home. What are some ways you use electricity every day, and how does the energy flow to make these devices work? So, these are the materials that you will need for this activity. You will need your journal or your paper to make your observations. You are going to draw this data table in your journal or on your sheet of paper. And I'm going to show you this data table blown up in another slide. And then you'll need a highlighter or crayon to trace our circuits with that you will be drawing. So, you are going to take a walk through your home to find devices that use electricity. You're going to list the devices here and you're going to describe what they are used for. And then you're going to record if they use electricity to produce light, heat, and or sound. Okay? So Ms. Douglas took a walk through her home and I did list some devices here. And I just want you to kind of predict as I move along through the chart what you think will come up in each box. So my first device is a television. Okay, our television is used for entertainment. It is used to entertain us. Okay, now think about your television. I want you to walk up to your television, or your computer is an equivalent. Walk up to your television. Look at it. Does it produce light? My television produces light. That's how I am able to see the picture. Does your TV produce heat? Newer TVs don't produce as much heat as the older TVs do, but they still produce some type of heat. They still let off some type of energy out the back. If you look on the back of your TV, you might see some vent holes on the back of it. That is to let out the heat. And does it produce sound? We know that TV's sole purpose is for us to watch and to hear the sound that is coming out of it. So yes, our TVs do produce sound. Okay, so you're going to take a walk through your home. So pause this here and go and fill out the rest of this chart, finding devices in your home that use electricity. I'm going to continue with the things that I found in my home. My remote control to the television. Now, I do have two types of remote controls. We have a Xbox remote control, which I know a lot of y'all have some type of gaming system, or a television remote control. Okay, so depending on which one you're talking about, can depend on what you will put in these boxes. So a remote control, any remote control, is used to control a device. Okay. Now, the one I am speaking on is the TV remote control. And does it produce light? Sometimes it does. My Xbox controller does produce light. My regular TV controller does not produce light. It just depends on the type of controller that you're speaking about. Does it produce heat? No, neither of my controllers produce heat. And no, neither of my controllers produce sound. Okay? My refrigerator. My refrigerator is used to keep food cold. Does it produce light? We know our refrigerators produce light. They produce heat. And my refrigerator does produce some type of sound. When you leave the door open too long, it'll ding and it'll let you know, hey, your door is open. The ice machine makes sound. Okay, so some refrigerators do produce sound. And my car. My car is used for transportation. My car produces light with its headlights, its interior lights, its tail lights. My car produces heat, okay? And my car produces sound. So make sure you have this written down on your piece of paper or in your journal, okay? So, how are all of these objects able to produce electricity? Okay, so going back, because I didn't mention this, all of these devices have to have some type of electricity to function. My television is plugged in. My remote control uses batteries. My refrigerator is plugged in, and my car uses a battery to stay on. Okay, as well as gas, but without the battery, my car would not work. Some cars also could be plugged in, electric cars. Okay, so all of these devices use some type of electricity, whether it's plugged into a wall or whether it's using a battery, in order to function. So in order for those materials, not materials, devices to function, we know that we must have a closed circuit. Okay, we use electricity for many different devices in our homes and schools. For these devices to work, the electricity must be able to flow in a complete circuit. If the circuit is open, the device will not work. Okay, so this switch here is just like the switch in your home. What I want you to do is go and flip your switch into the on position. Your light turns on. When the switch is closed, that means there is a complete circuit. There is a complete path for that electricity to flow through, and therefore your light will turn on. If you flip that switch off, that circuit is now open. It cannot, the electricity cannot continue to flow through because your circuit is open. Okay. So we're going to watch this quick brain pop video. And I want you to pay attention to these different vocabulary words: current, open circuit, closed circuit, battery, load, switch, conductor, and insulator. Remember, guys, this is a review. Some of you may have already seen this video, but this is just a refresher to remind you of how electricity flows in a open or a closed circuit.
Current.
Okay, and I'm going to start it a little later in the video just to get the meat of what I want you to know.
Useful as a power source because all the energy is released all at once. Ow. In order for electricity to be useful, we need a steady flow of it, a current. An electric current doesn't just happen on its own. It needs a path to follow. And that's what a circuit is, a path that a current can flow along. Well, yeah, but you need more than just a wire. Even the most basic circuit is made up of a few different components. First, there's a power source, like an outlet in the wall or a battery. The power source provides a steady supply of electrons. In the battery, the electrons come from the negative terminal. From a wall outlet, electrons come from the shorter of the two slots, called the hot slot. The electrons need a path made of a good conductor, which is any material that allows electrons to move through it easily. Most metals make good conductors, so we use metal wires as a path in electric circuits. Yeah, the wires are surrounded by rubber or plastic because those materials are good insulators. Insulators are kind of the opposite of conductors. They're materials that electrons have a hard time flowing through. Insulated wires keep electrons on course, and they protect us from the dangerous flow of electricity going through their metal cores.
So if you go and look at a plug in your home, television, lamp, any toaster, any plug in your home, and you look at the wire, you will be able to see that that wire, that copper wire that is inside of it, is covered with some type of insulator. That insulator is there to protect you from being shocked, because you know that conductor, that copper wire that is inside of that plastic or rubber, is allowing electricity to flow through it. If you were to touch that wire, you will be electrocuted or shocked. That's why it's important that all of your wires are always intact and covered with some type of insulator. And if they become damaged or broken, that those devices be fixed or thrown away, so that no one in your home will hurt themselves.
Along the circuit's path, there's usually a load, a device that uses electricity. Electrons flow through the device, giving it power. When they
Now remember, our electrical current flows out of the negative terminal, out of the negative end of the battery, into the positive end. That is the only way that you will have a complete closed circuit, is if that electrical current is able to flow out of the negative terminal back into the positive terminal.
flow out of the device, they head towards the opposite side of the power source. In a battery, that's the positive terminal. In a wall outlet, that's the taller of the two slots, the neutral slot. And that's the real key to an electric circuit. The electrons have to have some place to go. Without a somewhere to flow into, the electrons will stop moving and you no longer have a current. If you look closely at an electric cord, you'll see that it's actually two separate insulated wires. Electrons flow out of the hot slot, down one of the wires, into the load, through the wire on the other half of the cable, and back into the neutral slot. Oh, right. Well, to control whether an electric device is on or off, you need a switch. A switch controls the flow of electrons by opening and closing a circuit. When a switch is in the off position, the circuit is open. And when it's in the on position, the circuit is closed and the electrons can flow through. Whoa. I think you've had enough. Uh-oh. Well, now you've gone and done it. Oops is right.
And guys, I will leave the link to this brain pop video so that you can go back and rewatch it and look at the quizzes and answer the questions on this brain pop video. So we're going to continue on to the next part of our activity. Okay, so now we're going to apply what we have learned. Here's where your crayon or highlighter comes into play. You're going to draw, unless you have a printer. Miss Douglas's printer stopped working, which is why we had to do it like this. Otherwise, I would let you see me do this in real life. But if you have a printer, you can print the file that I will have in the folder, or you can simply draw the circuits, guys, and trace them. The program that I'm using to trace these circuits on is the Paint app. Most, if not all, computers have this app already installed on their computer. Okay, so that's what I'm using to trace them. And you can do the same if you are on a laptop or desktop. Okay, so now we are in our paint program, and we are going to do this one together, and then the last two you're going to do on your own and submit them back to me for extra points. A lot of you guys are doing not so well on your social studies, so I would use these extra points opportunity to get some extra points on their social studies and on your problems of the day. So I'm going to choose just any color. Okay. So we know that we always go out of the negative terminal. So all I'm doing is tracing my circuit to see which bulbs will turn on the way that the circuit is built right now. Okay, so I have 5 LED lights and 1 switch and 1 battery. Okay, so I'm going to trace my circuits to figure out which LED lights will light up in a complete circuit. Okay, so we're out of our negative end. We're passing this LED 1, and I'm going to go this way first. We're passing this LED 2, and we have to stop right here. We have to stop here because our switch is open. Okay, so I'm just going to circle that open switch and put a big X through it because no electricity can flow through that switch. As long as that switch is open, no current can flow through it. Okay, so I'm going to change my color and I'm going to try and go a different way. So I'm still going out of the negative end of my battery. And instead of going right, I'm now going to go left and follow this flow, passing LED 3, going through LED 4. And remember, to make a complete circuit, we have to make it back into that positive terminal. I'm going to go this way and try to light up LED 5. I have to stop. Why do I have to stop? Because my switch is open, okay? Electricity cannot flow through an open switch. So I'm just going to cross it out again because LED 1, LED 3, LED 4, and LED 5 did not light up because I did not make it back into the positive end of that terminal. So I'm going to choose another color because I still have this one path left that I have not traveled down. So I'm going to go again out of the negative end of my battery over LED 1, LED 3, LED 4, and then I'm just going to go back up into the positive end of my terminal. So now that I've made it back into the positive end of my terminal, I know that all of those lights on that blue path will light up. So that makes LED 1 and and LED 3 and LED 4. So the only light bulbs that will light up in this particular circuit is LED 1, LED 3, and LED 4. Okay, so this is something that you can do on your own with different color highlighters, crayons, markers, color pencils, whatever you have at your home. Draw the circuit out or print the circuit out and trace it. Or do what I did and paste a picture of the circuit into the Paint app and draw it like this and then snap a picture of it and send it to me. So I'm just going to go through and show you the rest of the circuits. Okay, this is the one we just completed. This is the second one, the third one that you can do. Okay? And this is your journal entry. So I'm going to also put the link to this Google slide in the folder as well, so that you can go to this slide to do the circuits online. You can explore how to make the circuits online, and that can you can explore how to make the circuits online, and that can help you when completing this journal entry. Draw a circuit with 4 light bulbs and 1 switch. In this circuit, 3 bulbs will light when the switch is open, and all 4 light up when the switch is closed. Explain why 3 bulbs will remain lit when the switch is open. Okay, so complete that journal entry, and I'll click on here so you can see what it is like to go through the interactive circuit building. I'm going to do the intro. Okay, and then you will just build the circuit. Okay, you know you have to have a load, you have to have wires, so you will build those wires any way that you would like to. You can turn them. You know you need a light bulb, and you know you need wires to connect it back. You can use add a switch, and make this however you see fit. Okay? Alrighty, guys. Well, you have any questions, just let me know. I'm here. You have my number. You can call me. You have my email. Okay? Let me know if you have any questions. Have a great day.